So after you have learned the machine learning, it's quite amazing, right? So you give the computer some input, some expected output. That means the image and also the label. So the computer can find the feature, so they can find the relationship, and then they can start to do the classifications for your image, and then put the correct labels for your image. Okay, but one of the most important thing is, yeah, computer is binary. That means 0 or 1, 0 or 1, 0 or 1. Okay, it can be numeric because the numeric number can be changed to binary number, but at least it must be some numeric. Okay, 1, 2, 3, 4, 5, 6, 11, 12, etc. Okay, so it comes to another problem: how to change the image. Okay, change the image that we have captured into numeric. Okay, into numeric data form. Okay, so we have another topic called comparisons. Okay, comparisons. Comparison is here, is a set. Okay, machine learning is here. Okay, so machine learning can handle different problems. They can handle the recommendation system. They can handle the AlphaGo. They can handle different kinds of problems. Okay, it's not only limited to the image. Okay, but they can also apply to the image. That means the comparisons. Okay, and then the deep learning that we are using is here. Okay, so deep learning here is the subset of the machine learning, and deep learning is also able to apply to comparisons. Okay, to solve lots of the different problems. But again, the first problem is how you can encode the image into the primary things. Okay, so here is our human brain, right? So we capture the image, we see the image from our eyes, and then we go to eyes is here. Okay, and then we process our the image, okay, by our brain. Okay, and then we can classify it whether it's an apple, orange, banana, or other kinds of object. Okay, computer, we have the similar flows. Okay, so we have the input. Okay, is an image, is the light, and then we use the sensing device. Okay, sensing device, we have different kinds of sensing device. It can be a camera, a webcam, a RGB camera, or RGBD camera. Okay, we will explain later. And then we change the this kind of image into some discrete signal. Discrete signal. That means we try to turn it all the thing into 0 and 1. Okay, I will explain later, and then process by the computer. Okay, so if you can turn the image into 0 and 1, so we can do lots of different kinds of things inside the computer, including the machine learning. Okay, so that is what we are going to study in this part and in this topic. So there are a couple of terms you need to understand before you go deep. Okay, so you need to understand what is your data source. Okay, so there are lots of the terms inside your data source. That means the image that you need to know. The first one is pixel. Pixel. Pixel is the smallest value of your image. So for all the image, okay, it will be transformed into lots of square. Okay, lots of square. Okay, so for each square here, we call it a pixel. Okay, a pixel. That when there is lots of the pixel together, it forms to image. Okay, it forms yeah, here we have the image. Okay, and when there are lots of image goes together, so we have the videos. Okay, so computer is like that. So we have different kinds of pixel form together, and we have image, we have lots of different image, and then we have videos. So here is a image. Okay, here is a image. Okay, and then we try to encode each image into a digital signal. Okay, so what we are going to use, we are going to use a color code here, color code. Okay, just a minute. Okay, color code. Okay, so the color code, we have different kinds of color code system. So if it's a color code from lighting source, for example, your monitor, for example, the projector, they are producing the lighting source, then we use the RGB RGB encoding, okay, red, green, and blue. If it's a printout, so we will use the CYMK and other kinds of things, okay. And then we use the color code, and then we turn all the color into red, green, and blue. For all the color, we have a degree for it from 0 to 256. Okay, 0 to 256. Okay, 0 to 400. In fact, it's 255. Okay, so we have 256 value. It can be a 16-bit. So sometimes we use after 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go to A, B, C, D, E, F. Okay, so if there is a value called FF, okay, that means it's 255. Okay, so now we turn each pixel into a color code. Okay, so here we have lots of the color code, and all this kind of color code. Okay, so they represent a value from 0 to 255. Okay, so it becomes the numeric data. Okay, and we combine all the numeric data together, and we can use our machine learning, or we can use our deep learning extra inputs, and then put it into our neural network model and then process. Okay, so there are different resolutions. Okay, because we have lots of different pixels, right? So for this image it should be 12, okay, times 16. Okay, 12 times 16. Okay, is the width and also the height of this image. So most likely for the webcams, it should be 320 pixels times 240 pixels. Okay, so of course, if you purchase a better webcam, it can be a 720 pixel p, or HD 1080 pixel p, or even 4K. Okay, even 4K. Again, if you have a better camera, so that you can capture more pixel at the same time. Okay, but it also turns out you need to have extra computation power to process the image. Okay, so if we combine lots of the image together, and then it becomes a video. So for the videos, we have the frame per second. That means for each second, how many images that we can process. So most likely in the webcam is 25 FPS frame per second. So this kind of image you need to bear in your mind, because when you are used for the training, or if you are using for the data processing, okay, if you increase the resolutions or increase the FPS, okay, it will exponentially increase your training times. Okay, so don't think that if you get a 4K camera, so it's the best situations for your applications. Okay, in fact, you are exponentially increase your computation power, and then you need unpredictable, unexpected time to train up the model. Okay, it wastes your time. So for the hardware, there are two different kinds of camera. The first one is RGB, okay, red, green, blue camera. That means the webcam, that means the camera on your mobile phone, etc. Okay, it's a normal camera. It returns the RGB value. So most likely they have a higher resolutions. Okay, so even your webcam is 322 times 240. Okay, it's better than the RGBD depth camera. Okay, depth camera. So today, beside the RGB camera, we also fun camera, right? So beside the RGB camera, we also have the infrared camera. That means the depth sensor, the depth camera. Okay, to find out the 3D structure, or find out the depth of the object. Okay, so here is the depth of the object. Okay, so in RGB camera, they cannot recognize the color. They can only recognize the depth. Okay, so they know that this guys is in front of the camera, and then they can try to classify the background. Okay, here, and also the human. Okay. If your depth camera, they have a better resolution, so somehow they know the 3D structure of your face. They know the 3D structure of your object. Okay, So it's quite good, especially we are doing some motion sensing, or especially is used for the security. For example, your iPhone and also the Surface Book or Surface Pro, maybe, yeah, Surface Pro, they have two camera. Okay, they have two camera, because if you are using RG camera only, so somehow some of the bad guys, they will capture your photo. It's easy to find your photo on social media, whatever is IG or Facebook, right? So they can capture your photos and then they can hack the camera. But if you have the depth camera, so somehow they will store the information of your 3D structure of your the 3D structure of your face. Okay, so it makes the hacking, it makes the security become better. Okay, they improve the security. Okay, because it's also collect the 3D structure of your face, so that you cannot just print the photos, or you use another iPad to cheat your camera. Okay, it costs is lower resolution. Okay, most likely is 180 times 120. The resolution is lower, and it costs extra computation power to your PC. Okay, and yeah, it only returns a single value. That means the depth, the distance between your camera and the real physical object. Okay, but most likely, of course, for your deep learning, or for your Quizlet, so somehow you can also put the information of RGBD sensor if they have this kind of information, because for the RGBD sensor, it only provide the depth value, and then depth value is the distance. Okay, it's the distance of each pixel. So it's also a numeric value. It's easy to put inside the network. But bear in your mind, not all the PC or not the clients, they have this kind of settings. Okay, so you need to make sure that if you use the depth sensor, your application will be limited. So in computer vision, so there are lots of typical tasks, or we say applications. Okay, applications. So the commonly application is pattern recognition or image classification. That means your task. Okay, your task in this project. So you maybe want to recognize the not to $100, $200, etc. Right? Maybe you want to recognize some physical object, maybe apple, orange, or banana, etc. So this kind of thing we call it pattern recognition or image classifications. Okay, so there are lots of the things we can do. We can use the deep learning, we can use the feature extraction, etc. We can combine them together and use. Okay, and then beside this kind of application that you will create in this project, so there are there are lots of different other applications. For example, the facial recognitions. Okay, identify the people in the photos. Okay, so this is one of the good example that you need to use. Okay, so every day you unlock your iPhone by using your front camera and infrared camera. So this is one of the application. Or you use the camera to take the photo, right? So they will recognize the people face, okay, our human face, and then they will try to focus our human face when you are using the smartphone to take photo. Okay. So beside the pattern recognition or image classifications, we can also use the computer vision X, the motion analyze. Okay. So you can analyze the 3D widget motion, so you can analyze the movement of your body. Okay, so you can also analyze some interesting points. So Kinect will be one of the interesting application, and all different kinds of VR applications. Okay, VR applications will be also apply into this area. Okay, and then you also have the scene understandings. That means when I capture an image or I have a videos, so they try to analyze all the object inside the videos and then tell you the meaning, okay, the meaning of this image. These kinds of setting, it really helps the VIP, visual impairment people, or we call it blind people. If you want to learn more, so you can go to the Microsoft Seeing AI. Google also doing the same things. So this is the project that how the VIP blind people can be helped by the technologies. Okay, so here is the link, so you can go to Google or YouTube, search this kind of information, and then have a look with the videos. It's quite amazing. Okay. So how to do the computer visions? Okay, so there are different kinds of method that you can do. Of course, you can use the machine learning. You can use the deep learning. You can use the CNN. You can use the Skillslab to do these kinds of things. Okay. But many years ago, when we do not have the deep learning, that not many years ago, it's only 10 or 15 years ago. So maybe we need to analyze the image and then by different AI methods and then extract the feature. Okay, extract the feature. This is one of the things that we do. And it also, computer visions also produce lots of the interesting pre-processing, okay, or enhancement application. For example, this is the image of our eyes, okay? Okay, this is the image of our eyes, okay? It captured by Canon camera, I remember, okay? So we need to do some pre-processing before we put into deep learning or put into machine learning model. For example, we want to filter out the other information that is captured by the Canon camera, for example here, right? We want to filter out all the things outside. We only want to the image. We only want the photo or the machine learning model to focus on the eyes. Okay, this part. Okay, and perhaps you can add some color filter to it, and perhaps you can scale. Where is it? Scale, rotate, or filter out some interesting or some important pixel to the machine learning model. Okay, so this kind of things we have to do it, and then we need to do it. Okay, and then there are lots of different kinds of things. So you can also try the detections or segmentation. Okay, so computer visions, besides using the deep learning or machine learning, there are lots of different methods how to do the segmentation. That means try to separate the object. Okay, so we can here separate the object. This one is human, and then we have the foreground, we have the background, we have the tree, we have the car, etc. So this kind of applications is also, or this kind of method is also commonly used in computer visions. And in your project, perhaps you use the computer visions, right? And then don't think that machine learning, they are all the things. Sometimes you need to set up a good physical environment for the machine learning to capture the image data. You need to scale, you need to rotate, or somehow you need to let the machine learning to learn the background first. Okay, to learn the background or foreground first before they start the learning. Okay, always remember this kind of pre-processing or this kind of enhancement, we help the machine learning. It speed up all the process and increase the accuracies for your model. Okay.